Welcome to my channel. Today we'll be looking into this very interesting concept that is transformation. When I say the word transformation, there are four subtopics that we have in O levels. So the first one that we have is something we can call as rotation. Now, whenever I talk about rotation, you need to realize there's two important aspects to a rotation. The first has to be the direction. So when I say what kind of direction would it be, you can say that it could be either clockwise or perhaps anti-clockwise. In a similar way, the second important aspect to this is the angle of rotation that we have. So maybe we might have something which is 90 degrees, maybe something as 45 degrees, could be even 110 degrees as well. And similarly, we might have something which is 180 degrees. Now, this 180 is something that is, I would say, probably in the gray area. Now, what is that supposed to mean? So when I say the word 180, you need to realize that you can't write down the word clockwise or anti-clockwise. Because if I were to rotate something by 180, if I were to move in clockwise or anti-clockwise, I still get the same position. Which is why whenever you express 180, you just write down rotation, comma 180, and then finally the third aspect, which is the center of rotation. Center of rotation. Now, this is, I would say, there's a lot of confusion when it comes to center of rotation. So ideally, in my view, there are three ways of doing this. The first has to be by using the tracing paper. Now, this is something I'm pretty sure not everyone is going to be comfortable with. The second one is by counting boxes. Counting boxes. It does require one to be smart. And the third probably has to be the best method, which is the perpendicular bisectors. Now, I know the concept of perpendicular bisector is no longer a part of the new O level / IGCSE exam paper, starting from 2025. But still, if you were to inculcate this approach within your method, I can promise you that you will get the correct and very precise center of rotation without making any mistake. In a very similar way, there's another, I would say, subtopic that we have, which is reflection. Now, when I say reflection, that means something that is flipped. In other words, you need to realize that something that is a mirror image. And generally, there are four types of reflection which are most common. I'm not saying these are the only ones that's going to show up. I'm just saying that this is something that does show up very often. So the first one will be the reflection along the line y is equal to x. The second reflection is something that is along the line y is equal to minus x. The third reflection is something that is about the x-axis. Now, this is something that you should be careful about. When I say reflection is about the x-axis, it has the same meaning as saying y is equal to 0. If you check out the marking schemes before 2019, you'll see that it only mentions this as the answer. Although even back then, quite evident that both of these answers are acceptable. I would expect that you should write down only one. If you ask me, I think equation is better. Ideally, it doesn't make any difference. In a similar way, the fourth kind of reflection that comes very often is something that is about the y-axis, which is also known as x equals to 0. Now, again, 3 and 4, which they do show up very often. I'm not saying these are the only ones. I'm just saying this is something that does show, that does show up. Finally, we have something which is enlargement. I personally am not a big fan of the word enlargement. The reason why I say that is because when I think about enlargement, to me in English, the vocabulary, that's what I like to think. It means something that is getting bigger. But if we talk about enlargement, that's not always the case. So in enlargement, there are two things that you should mention. The first has to be the scale factor. And the second is, of course, the center of enlargement. And that is perhaps way easier than the center of rotation that we just discussed. Now, when I say the word scale factor, there are three types of scale factors that we have. Let's say there's a scale factor of 3. Maybe perhaps there's a scale factor of 1/2, or maybe there's a scale factor of -2. Now, when I say that the scale factor is 3, that means the image that you have has been enlarged 3 times. In a very similar instance, when I say the scale factor is 1/2, it means that somehow the image is diminished. Now the it has, as in it got smaller. So you see what I'm talking about. When I say the word enlargement, it means something that's getting bigger. Whereas when we talk about a scale factor which is 0.5 or 1/2, it means now the image has been reduced by 1/2. And finally, we have the negative scale factor. So we can say there are 3 types of scale factor. The first one is positive, the second one is fractional, and the third one is negative. When I say there's a negative scale factor, that means the image has been inverted. It's getting bigger. 2 means it's getting bigger, but minus means it has been inverted. So maybe it was facing upwards. Now it's going to be facing downwards, but 2 times bigger. And finally, we have translation, which is quite simple, which means moving left, right, up, or down. Now, to all of those who are watching this video, please bear this in mind. For any question about translation, it is a mandatory step for you to mention the translation column vector. That means if I ask you what kind of translation is happening, you are supposed to write down the answer in terms of a column vector. So I hope that is clear. If the gist of this topic is clear now, we can jump on to some past paper questions. Before I continue, I'm just going to skim over this syllabus guide that I've actually attached. So in this worksheet, the very first thing you see is the syllabus guide that I've taken a screenshot of. It says the students or the candidates should be able to recognize, describe, and draw the following transformation. So you do understand there are 2 types of question. One where they ask you to draw. The second is where they ask you to identify. So that's exactly what they're saying. Questions may involve a combination of transformation. A ruler must be used for all straight edges. When I say a ruler, that means everyone, you should be using a ruler. For instance, if I'm having a triangle and you're done moving the new triangle, you're done rotating, reflecting, whatever was happening, you're supposed to join it. You're supposed to join the vertices with the help of a ruler. So the second point over here says rotation of a shape, blah, 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 about a center through multiples of 90. Now, over here it says multiples of 90. That probably indicates that somehow you might get 90, you might get 180. A question that I get is, can we get 270? Honestly, if they give you 270 clockwise, you should understand that it actually means 90 degrees anti-clockwise. 90 degrees anti-clockwise. So when you're drawing this out, it shouldn't be that hard. Finally, enlargement of a shape from a center by a scale factor. Like I've already discussed, there are 3 types of scale factor. The first one is positive, second fractional, and then we have negative. And finally, we have a translation which must be represented with a column vector. Now, without wasting any further time, let's dive into the questions. The question over here says the diagram shows triangle A and B. And they're asking us to describe fully the single transformation that maps A onto triangle B. Now, back when I was explaining the concept about rotation, I did mention that there are 3 ways to identify, or 3 ways of doing or finding the center of rotation. When you look at this question, you should be able to reach to this conclusion that somehow this is a rotation happening. So this question is worth 3 marks, and the first mark will be awarded to you if you write down the word rotation. If you identify the rotation, if you identify the transformation, you get your first mark. So I do expect from everyone to at least write down this part. You should be able to recognize what's happening. The second has to be, what kind of rotation is it? What kind of direction are we moving in? So I can clearly see that it's going in this direction. Now, this is something where I used to get confused a lot as a student. So if you're kind of confused as to whether it's clockwise or anti-clockwise, in your CI exam hall, there's going to be a clock right in front of your row. Just work out, as in using that as well as to how clockwise moves. So if you feel like you're confused, you should know the clock always goes in this direction. So I can clearly see this is moving from 6 all the way to 9. So this has to be a clockwise shift. Clockwise, again, in which, as to what the angle is going to be, I can clearly see that's 90 degrees. And the third part has to be the center of rotation. That is the most interesting part. Now, if you want to mention or identify the center of rotation, like I said, the best way of doing that is by drawing the perpendicular bisectors of any two corresponding sides. What I'm trying to implicate over here is take your compass, place it on this point, make an arc on this side. Using the same opening, place the compass over here, do the same. Join this line. Do the same for another set of points, and these must be extreme points. If you do it for these 2 points as well, you should get the point of intersection, which is going to be the center of rotation. That's just one way of doing it. The second way is, of course, by using the tracing paper. Unfortunately, I can't really do that over here. And the third one is by counting boxes. When I say counting boxes, then that means you have to be a little rational in your decisions. So when I look at these 2 points, what's the distance that I have? Let's see. So if I were to look at this, you can see that it's 1 diagonal box, 2 diagonal box, 3 diagonal box. That means this point, this vertex, and this vertex is almost 3 boxes away. What's half of 3? I know it's 1.5. So here's what I'm going to do. I'm going to make a line which intersects this line that I've already drawn exactly in the half, as in exactly halfway. So you can see on both sides, we're having 1.5 box and 1.5 box. Now, I'm very certain that my center of rotation should be on this line. It could be this, it could be this, it could be this, it could be this, this. All these could be my potential, center of rotation points. Now, this is where the counting actually comes in. So I can just start off from any random point. If you check out this point over here, you can see that this is almost 3 boxes away. And this box is also 3 boxes away. And you can see this is somehow the rotation of 90 degrees. The distance from the center to the vertex should also follow the same tradition of rotation, as in it should also follow the same convention in which the rotation is happening. In a similar way, how far is this box? We can say it's almost 5 boxes down and then 1 left. In a similar way, how far is this? That is also the same. That clearly indicates that this point is my center of rotation, which is 2, 1. I know it sounds kind of hard, and you might be wondering as to how can you just randomly pick a point and that comes out to be the answer? Well, I've done this question before, that's how I know. Maybe I might have taken this as well. But if you think about it, this box, or this point is almost 1, 2, 3, 4 boxes down and 1 left. Whereas if I were to apply the same approach over here, that doesn't give you the same answer. So I hope you're able to build up, as in that um, that that correct thought or the thought process that actually gives you the answer. And I've always told you that there's always a cheating hack which is allowed in the exam. Take your compass with you, draw the perpendicular bisectors. Yes, that's going to take 1 minute of your precious life, but it will give you the correct answer. So I don't know about you, but if I were you, I would definitely use that option. In a very similar way, let's do another challenging question. So I'm just going to scroll on to question number 4. Now, when you look at this question over here for part A, it says that we have described fully the single transformation that maps A onto B. I must remind you, everyone, that this worksheet that I've made is something that's relatively new, and it contains questions, from the recent past papers or the specimen papers of IGCSE and O levels. Now, in this case over here, I can clearly see this is how the diagram is oriented. And somehow you can see that this is where the pointy edge was. And now the pointy edge went all that way. So just by looking at it, I can secure my first mark by saying that it has to be rotation, comma, the second part, which is to identify how is this happening. So I can say this has to be 90 degrees anti-clockwise. And the third has to be the center of rotation. Now, again, this is where it becomes a little tricky. Now, I don't expect you to actually count the boxes and then make a line halfway. To be very honest, this approach is not going to work for long. And that is exactly what you need to understand, that this approach is maybe good for a question. It's not going to work all the time. It does, but it's going to keep you in that circle where you keep doubting yourself. I don't want that to happen to you. So I would highly recommend, again, take any two corresponding points. You could maybe take this or perhaps take this. Place your compass on this point, make an arc on this side, make an arc on this side. With the same opening, make the same arc on these 2 points as well, and then take your ruler and join this. Do the same for another set of points, maybe perhaps for these points. I'm just gonna color this black. Do it for this as well. Again, this is the distance that we are dealing with. Open it more than half. Make an arc on this side, make an arc on this side. Do the same for these points as well. And again, and you will realize that it does intersect exactly, where they wanted us to. As in, that's exactly going to intersect at the center, which is in this case going to be 0, comma 0. So you can see that in this case, this point is almost 2 boxes away and one up. The same approach is over here as well. So you can see that the center and the vertex, they're having the same rotation throughout for all the points. So again, that's just how you do it. You can keep guessing, you can keep trying different numbers. I've seen many students struggling with this. They keep thinking maybe this, maybe this. I'm not gonna recommend, that approach. So again, this is how it works when it comes to rotation. I hope everyone this made sense. We'll probably continue in the next video with some more examples. Till then, adios.